Thank you all. Thank you, members of the panel and colleagues. It's a pleasure to be here. And you have to put up with me for 2 papers in a row, so bear with it. This first one is about cataract fragment phaco coupling, and this is an interesting phenomenon which I'll explain to you. This research was performed at the AMO laboratories, and I have to give them credit because this was an expensive setup, and they allowed me unrestricted use of the findings. We all know that there are certain trends in phacoemulsification which include power innovations and flow innovations. The power innovations have to do with micropulse phaco, and micropulse phaco by definition is also a flow modification. So I'm going to talk about these 2 modifications. We used a fast cam that you see right here, which will take high resolution photographs at 10,000 frames per second. We selected 3,000 frames per second because of light issues. What happens during emulsification is that even though we're using pre-occlusion phaco, pieces of nucleus come to the phaco tip. As you see here, this piece of material is at the phaco tip. And as the phaco tip vibrates at its frequency, which at 40,000 cycles per second, you can see how it shimmers at the edge. So this piece of material is actually coupled with the phaco tip. Coupling means that the material is held by the phaco tip and moves with it, although it is not actually attached to it. I have to move off to change. So what happens is if we look at the common balls that we used to keep on our desk, you can think how energy can move through the material. So we see as these balls work, do we have sound with this? So one ball hits the next and it transfers through the balls till the final one flies out at equivalent energies as the one that hit it, with very little energy loss. Well, we can imagine the same thing happens with the fragment. So I did an experiment. I took a glob of glue, which you see right here, and I glued that onto the phaco tip. Now you'll notice that the glue is not stuck to it, it's just on it and moving with it, but separate from it. And I did enhanced cavitation, which means I suspended this over a water bath, and here's what it looks like. And you'll hear the sound of phaco. We could use sound with this also. And you can see right over here all this energy that's coming off the glue glob. So energy is indeed being transferred through the material. So here we see it one more time. Regular speed, it just disappears. You'd never know this is going on. But in high speed, you can see the movement of the material on the phaco tip coupled to it. Now the next thing to do is imagine that on its distal surface over here, that all this energy is being radiated. Now none of us really know what causes corneal edema and what causes endothelial cell damage and what causes damage to the blood aqueous barrier, free radicals, phaco energy. But what I'm proposing is that it's possible that the energy that's coming through this fragment is hitting up against internal structures of the eye and causing damage to these structures. So coupling means that the fragment moves with a phaco tip at ultrasonic speeds. It becomes an emitter. The fragment itself becomes an emitter of chaotic energy because what's coming off that fragment is not in any way controlled. It's coming off at all different points at different energies, and that can be the cause of damage to the blood aqueous barrier, endothelium, and may cause the release of free radicals. So how do we minimize this? Well, number one, we have to use adequate energy. We have to use phaco energy that will emulsify the material rather than just push it around. We should use mechanical chopping whenever possible to help move material into the phaco tip. We should hold the fragment against the phaco tip when possible. Torsional phaco, interestingly, because of its ability to enhance pre-occlusion phaco, will automatically prevent it. And then we need to look at angle tips and ABS tips, which I haven't done yet, to see if these have a role. And so finally, if we can control these things, hopefully we can decrease corneal edema. The next phase of this study will be to use microprobes to actually analyze the energy being emitted, and I hope to report to you next year exactly how much energy is really being emitted by these phaco fragments. But coupling certainly seems to be an issue which we need to think about as we're performing phacoemulsification. Thank you.